What's up, Meowmaticians? Welcome back to another video. In today's episode, we are going to learn all about exponents. Yeah! Woo! Okay, so what is an exponent and what does it look like? Let's take a look at this expression, 3 to the power of 2. This is called an exponential expression and is split into two parts. There's a top and a bottom. The bottom number, which is 3, is called the base, and the top number, 2, is the exponent. In an exponential expression such as this, the exponent, or the top number, indicates how many times you multiply the base number, or the bottom number, by itself. In this case, we multiply 3, the base, to the exponent times, which is the same as saying 3 times 3. Okay, now, before we move on to something a little bit more complicated, make sure you get these. All good? Great. Okay, let's move on. So, for the first one, 3 to the power of 4, we need to multiply 3, which is the base, 4 times, since 4 is the exponent, to get 3 times 3 times 3 times 3, which equals 81. For the next question, we need to multiply 4 3 times to get 4 times 4 times 4, which equals 64. For the last question, we need to multiply 2 5 times to get 2 times 2 times 2 times 2 times 2, which equals 32. Now let's figure out how to add, subtract, multiply, and divide exponential expressions with each other. The cool thing for you is that you actually can't add or subtract exponential expressions, which will make it easier for you to learn. For example, 3 to the power of 4 plus 3 to the power of 3 would not equal 3 to the power of 7. 3 to the power of 4 plus 3 to the power of 3 is already in its simplest exponential form before you turn them into 3 times 3 times 3 times 3 plus 3 times 3 times 3. Okay, so let's move on to multiplying exponential expressions. Let's say I had 3 to the power of 4 times 3 to the power of 5. Let's break them down into the amount of 3's we multiply them by. So 3 to the power of 4 becomes 3 times 3 times 3 times 3. And then we multiply that by 3 to the power of 5, which would become 3 times 3 times 3 times 3 times 3. So now our entire expression looks like 3 times 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 3, which is 3 multiplied by itself 9 whole times. Thus, 3 to the power of 4 times 3 to the power of 5 equals 3 to the power of 9. This idea can be expressed as a rule. When multiplying exponential expressions, as long as both exponential expressions you multiply together share the same base, then the product will equal the same base with the sum of their exponents. So, for here, 3 to the power of 4 and 3 to the power of 5 share the same base, being 3, and the sum of their exponents, being 4 plus 5, equals 9. Thus, the product of 3 to the power of 4 times 3 to the power of 5 is 3 to the power of 9. Okay, so before we move on, try these out on your own. Ready? Okay, good. Let's go over them. So, the first one is a trick question. Remember, you cannot add exponential expressions together, even if they share the same base. So, 3 to the power of 4 plus 3 to the power of 5 cannot be simplified into a single exponential expression. Instead, it would be 3 times 3 times 3 times 3 plus 3 times 3 times 3 times 3 times 3, which equals 81 plus 243, which equals 324. Next, we have 6 to the power 8 times 6 to the power 2. Here, it's multiplication, which we can do, and they share the same base. So, let's just add the exponents. The exponents are 8 plus 2, which equals 10, and then we keep the same base as 6, thus our product will be 6 to the power of 10. Next, we have 5 to the power of 3 times 5 to the power of 8. It's the same as before. Let's just add the exponents. 3 plus 8 equals 11, keep the same base of 5, and thus our product is 5 to the power of 11. Lastly, we have another trick question. So, 9 to the power 2, also known as 9 squared, times 5 to the power of 3, also known as 5 cubed, is in fact multiplication. But these two do not share the same base. Thus, we cannot simplify them together to form one unique exponential expression. Instead, we would have to solve each individual exponent and multiply them together. So 9 to the power of 2, also known as 9 squared, equals 9 times 9, which equals 81. And 5 to the power of 3, which is also 5 cubed, equals 5 times 5 times 5, which is the same as 125. So we get 81 times 125, which equals 10,125. Now let's move on to dividing exponential expressions. Let's say we had 3 to the power 4 over 3 cubed. We can turn this into 3 times 3 times 3 times 3 divided by 3 times 3 times 3. If we cancel out the 3's on the top with the 3's on the bottom, we are left with a single 3 on the top, which is the same as 3 to the power of 1. Thus, 3 to the power of 4 divided by 3 to the power of 3 equals 3 to the power of 1. This is quite similar to the multiplication rule, but instead of adding the exponents, the quotient will have the difference of the top exponent minus the bottom exponent, and the exponential expression must also share the same base. All right, so now pause here and try these out. You got them? Good. Okay, so for the first one, we have 6 to the power of 5 over 6 to the power of 3. So we subtract the exponents, remember, top minus bottom, and keep the base. So the exponents of 5 and then subtract 3 equals 2. Thus, 6 to the power of 5 divided by 6 to the power of 3 equals 6 to the power of 2, which is 6 squared, which is the same as 36. Next, we have 8 to the power of 7 divided by 8 to the power of 4. Once again, subtract the top exponent with the bottom exponent. 7 minus 4 equals 3. Keep the base of 8. Thus, 8 to the power of 7 divided by 8 to the power of 4 equals 8 cubed. Lastly, we do the same thing again. So subtract the top exponent by the bottom exponent. 4 minus 5 equals negative 1. Keep the base of 4. And thus, 4 to the power of 4 divided by 4 to the power of 5 equals 4 to the negative first power. Now, this one's a little weird. What's weird about 4 to the power of negative 1? If you said the negative sign, you're correct. Are negative exponents even allowed? They are, and they also mean something unique. The negative sign means that the exponential expression with a positive exponent is being divided by 1. So let's try to make that easier to understand. For example, in this case, 4 to the power of negative 1 is equal to 1 divided by 4 to the power of 1. Similarly, 5 to the power of negative 3 equals 1 over 5 to the power of 3. All right, once again, pause here and try these out on your own. All good? All right, let's get it. So, pretty simple, right? So 6 to the power of negative 8 equals 1 over 6 to the power of 8. And then 3 to the power of negative 2 equals 1 over 3 squared. Okay, so now there's just one last thing we're going to cover in this video. What happens if you exponent an exponent? Okay, so for example, what does 3 squared and then that expression to the power of 4 mean? I want you to take a guess knowing what you know. This essentially means that 3 squared becomes the new base and 4 acts as the exponent. Thus, 3 squared to the power of 4 is as if you're multiplying 3 squared 4 times, which becomes 3 times 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 3, which is the same as 3 to the power of 8. Thus, whenever you raise an exponent to the power of another exponent, you can multiply the outer exponent, which was in this case 4, by the inner exponent, which in this case was 2. All right, once again, pause here and try these out on your own. You ready? Okay, cool. So for the first one, let's multiply the outer exponent 3 by the inner exponent 2. So 3 times 2, which equals 6. So 6 squared cubed equals 6 to the power of 6. Next, we just do the same thing. Multiply the outer exponent by the inner exponent. 3 times 5 equals 15. Thus the whole thing equals 4 to the power of 15. Now you know what exponents are, how to multiply and divide them, what a negative exponent means, and what to do when you raise an exponential function by an exponent. See you next time on Tiger Math. Also, find me on @CoolCalculations.